4, follow traffic, clear visual approach, runway 4 right, maintain 17, John Austin, 5 mile final. 17 till 5 out.
How technology is improving the safety of challenging landing approaches. From the National Business Aviation Association, this is Flight Plan. I'm Rob Finfrock. One of business aviation's most significant advantages can also be one of its most vexing safety concerns. We fly where the airlines don't, which means going into airports that may have additional challenges like surrounding terrain or encroaching airspace. And we often land at these fields utilizing visual approaches.
Some people feel like, what do you mean? We've been flying visual approaches since primary flight training. What's the problem?
Mark McIntyre is a CAM fellow and the director of a large Part 91 flight operation.
And so I went back and did not only a review of some of the literature, but even some of the recent incidents to give the audience a sense of the scope of the problem. So the NTSB published a safety alert. It's SA084 on circling approaches, know the risks. And they identified that there is a poor assessment of risks that result in unstabilized approaches on circling approaches, and that circling approaches don't allow for stabilized approaches. They talked about the transition from IMC to VMC, which can create an illusion of high speed, and they cited 10 accidents that had occurred during circling approaches that involved 17 fatalities. NASA Callback newsletter also did an issue on visual approaches and talked about instrument approaches being flown in poor weather conditions, and that visual approaches can present a number of hazards, particularly when localizer and glide slope indications are not used. NASA did a study called Problems with Visual Approaches, the Visual Trap, where they identified a number of issues with visual approaches, including several common visual approach hazards, often occurring at night. They said that people tend to accept visual approaches at any airport at night. They cited people accepting visual approaches at mountainous terrain and at night and not flying or backing it up with nav aids. There was also the issue of landing on the wrong surface, whether it might be a wrong airport, wrong runway, wrong taxiway. Most landings at wrong airports begin with a visual approach. So it kind of goes on and on and on.
But there looks to be a solution. Honeywell recently unveiled the FMS-Guided Visual Approach, or FGV approach, utilizing the aircraft's flight management system to fly through a series of additional waypoints on a visual approach, either by hand flying or coupled with the aircraft's autopilot. With more, here's Charlie Precourt, chairman of the Citation Jet Pilots Association Safety Committee.
The nice thing about it is that once it's loaded into your database, it can be loaded into the FMS just like any other instrument approach. And these in particular are designed as a charted visual approach to provide lateral and vertical guidance all the way to a short final. At Citation Jet Pilots, we have a number of members who are enrolled in our FOCO program, Flight Operations Quality Assurance, where we do flight data monitoring. And the data had shown over the last 2 years that the majority of our exceedances really came into the visual approach arena when they were not long straight-ins. Anytime somebody was doing a downwind or a base entry and setting themselves up, they were repeatedly, more than any other parameter that we monitor, encountering high sink rates in the base to final turn. And what we discovered when we looked deeper into it was people have a difficult time visualizing the required descent rates, spacing, geometry, because they're so variable. And what these charted visual approaches do is they take you through a series of waypoints that makes it very predictable to get you to roll out onto a wings level final above the stable approach gates. And so it takes a lot of the guesswork out of setting up a visual approach.
Mark, as you've noted, we've seen how improperly flown visual approaches can end in tragedy, including a pair of accidents that involve business aircraft flying circle-to-land approaches at Teterboro and Truckee Tahoe airports.
And even recently, we've seen a 121 carrier in Oklahoma City and in Tampa flying visual approaches that wound up extremely low, far from the threshold. So I would submit that flying visual approaches is a real issue. It's a real problem, and we need to find a way to mitigate that risk.
We mentioned Honeywell. I'd imagine other avionics manufacturers are working on FGV approaches as well, right?
Honeywell is on a mission to make these available more widely. So I know they're working and speaking with some of the other avionics OEMs to get the procedures loaded into the nav databases. So there's a strong effort going on there.
I see these proliferating over time. Folks in flight departments and other users can request assistance from the avionics providers now to incorporate these as Mark did with his flight department.
And I definitely want to talk about that. But Charlie, what's different about being able to fly an FGV approach over existing visual approaches, including the ability for users to enter their own waypoints?
A lot of the platforms that are out there today come with an ability to load, quote, a visual approach. But this is different. When it's a charted visual that is loaded in the FMS, it can have patterns that take you to avoid terrain en route to a final. And so a visual approach that comes with an FMS, say it's a Garmin or a Collins, where you can load a visual to a runway, is simply a straight-in leg. And you have to navigate yourself to that straight-in leg, typically 5 miles out with a 3-degree glide path. Those are not going to give you terrain clearance. They can give you some guidance for a lateral and vertical positioning, but they're nowhere near as sophisticated as these charted visuals. And like Mark was saying, Honeywell has begun making them available, and they will be crossing over into Garmin, Collins, and others as time goes on.
Sounds like this is definitely something we want to see in greater use across our industry. Mark, Charlie mentioned how your company worked with your OEM to create an FGV approach. Can you tell us about that?
Yeah, sure. So it's Jackie Cochran Airport in Thermal, California, which is just east of Palm Springs. It's an uncontrolled airport, has 2 intersecting runways, but the primary runway used by business aviation is runway 35 and 17. And landing 35, your pattern is constrained by very high terrain to the south, especially when flying a left downwind. We often go in there at night. It's a black hole approach. There are no approach lights. There is a PAPI, but obviously only visible once you've turned final. There's high terrain to the south. And there's no published instrument procedure that aligns you with runway 35. It's essentially an approach that comes in from the southeast, and then you have to kind of make a visual turn to final. We were seeing inconsistent performance down there. In terms of focal events and unstabilized approaches. We had actually developed kind of our own pseudo-guided visual just by developing a few waypoints that would put us on a left downwind and then kind of turn us onto the final. But the turn from the downwind to the final, the aircraft avionics didn't process it very well. It would give varying degrees of bank as it was trying to figure out where it was in relation to the final track. So it gave us some aid, but we didn't have a high level of confidence in it. I happened to be at a Gulfstream Operators Conference, and Honeywell was presenting on RNPAR approaches, and I went up to them after the presentation because we were interested in that as well. But the conversation then veered to these FMS-guided visuals that they're developing. And so I asked, we have an airport we go to. We'd love to have one developed for this. And in a very short time, they developed it, and we began flying it. Our focal events went to 0 at this airport, having the ability to use a procedure that gives you very positive and very accurate lateral and vertical guidance. So we come in normally from the northwest. Once we're cleared for the visual, we define a V path to the beginning of the downwind leg. So we fly kind of a nice constant final descent. We arrive at the start of the downwind leg on speed, fully configured, landing checklist complete, autopilot on. Both pilots can be heads up and simply monitoring the trajectory of the airplane, looking for traffic at an uncontrolled airport, monitoring terrain either visually or on the ground proximity display. And it just, literally took all of the anxiety, all of the sweat out of it. The airplane flies it extraordinarily well, as it's designed to do, and it allows the crew to simply monitor, and it rolls us out about 700 feet, AGL wings level, right on the PAPI, and at 200 feet, we click off the autopilot and land. It's a fantastic improvement in our safety profile at this airport.
The description Mark just gave is common in a lot of airports that business aircraft in particular operate to. And I call them the challenging airports. You have Henderson Runway 35 in Las Vegas. You've got Hawthorne nestled in next to LAX. They are very, very challenging if you look at them from a visual approach standpoint. The Hawthorne approach has close-in obstacles where the PAPI is not coincident with the LPV glide path, and it's a much steeper PAPI than the LPV glide path, and so there's a non-coincident glide path consideration there. At Henderson, you have terrain to the south, and to make the transition from that GPS approach to a PAPI, the PAPIs are not even usable until inside of 3 miles because of the terrain obscuring them. They're very, very complicated approaches. What the NetJets folks did at Henderson, they requested a charted visual there, and they actually have an approach that arcs around the terrain south of Henderson to the west side, and it makes a curvilinear path around the terrain to set you up on a nice final. And so these things are solving a lot of the challenges that you have to deal with if you're confined to what is currently published. So there's all these problem airports. Truckee is one. We talked about Teterboro. They're everywhere, and they have a number of different complexities. And that is really what is challenging pilots. Is there's not a consistent situation when you go to these different airports. You've got a different set of constraints, so you're kind of subject to making it up each time differently rather than having a standard flow. So as Mark saw down there, in his case, they can be really helpful.
Yeah, and these approaches also complement other efforts across our industry emphasizing stabilized approaches, including CJP's own Safe to Land initiative. Seems that FGV approaches are a logical next step in those efforts.
Absolutely. Mark just mentioned that the approach that they designed for him rolls him out wings level at 700 feet, which is above the visual 500-foot gate that people most commonly use. So it allows you to be stable. If you look at trying to fly, let's say you're a Cat C airplane and you're trying to fly a circling approach close to minimums, you'll find by TERP's criteria that Cat C approaches can have ceilings as low as 550 feet, I think it is, and visibilities as low as 1.25 miles. If you try to circle inside of those minimums, you will have a straight leg final that's less than 0.5 mile. And so you just can't be stable in that kind of situation. So although the minimums to a circling approach may allow you to fly something, you won't end up in a stabilized situation. So these charted visuals will set you up to get a stable final, and they're really, really helpful from that standpoint, because that's where we've seen high sync rates in the base to final turn. We've seen people with GPWS alerts for being below glide path, all kinds of things that happen in the close end game.
And Mark, as you mentioned, your FOQA data on unstabilized approaches into thermal dropped to 0 once that FGV approach was in place. That's the kind of result I think can't be overstated. We're right at the beginning of this process with one avionics OEM out front. Is it possible for operators flying with other platforms to bring this capability to their flight decks?
It is possible to essentially design your own kind of FMS-guided approach. About 2 years ago, I was in Croatia and we were going into Split, and there's a charted visual procedure to land, I think it's runway 22 or something like that, but it brings you on a left downwind kind of over the city and then arcs you just south of the terrain and rolls you on. And I thought, well, with a little bit of ingenuity, we figured out how to input a series of waypoints from that charted visual into our FMS. And I briefed the other crew member and I said, well, let's see how this works. Let's try flying this with the autopilot on. And it actually worked out really well. So it is possible to do that. You can go on the internet and find a table for bank angle versus speed, rate of turn. You can kind of figure out then from that how far you need to offset on a downwind leg to give you time to make a nice gentle turn at a reasonable bank angle based on the speed you're going to be flying. So it is possible to kind of design your own kind of pseudo procedure, which I would argue is better than no guidance at all. But because of Honeywell's and presumably the other avionics OEMs to code, especially radius to fix track legs, arcing turns. The beauty of that is that when you fly a radius to fix, regardless of your speed, it will keep you over the same arcing ground track. If you develop your own points, it's going to fly kind of a track leg, and based on crosswind and speed, it's going to vary your track over the ground. So when you develop your own procedure or try to develop your own procedure, although it might be better than a purely unaided visual, it's not going to give you the consistency of ground track that the Honeywell procedures will give you. The procedure works so consistently and so accurately that if and when it's available, there really would be no reason not to fly it.
Honeywell, I know, is accepting requests from any operator who would like to have an airport addressed. The other avionics providers are headed in that direction. It comes down to them designing it for the airport and then implementing it into the database that you would subscribe to. And it's just a question of time for that to happen. And I see it proliferating. If an operator has a particular need, like Mark did, they'll do it right now and they'll put a priority on it. And the other avionics providers are in the midst of working in that direction as well. We've seen already, just in the awareness factor, briefing people about this at CJP, the number of high sync rates and the base to final turn has dropped off dramatically. So I see these as a big boon to safety for us.
It's worth noting that FGV approaches aren't simply a benefit for smaller airports. They can also increase the consistency and predictability of traffic flows to large towered airports as well, enhancing safety even further as many commercial airports are seeing higher and higher numbers of operations. This is definitely a subject worth keeping an eye on, and I encourage you to check out the recent article about FGV approaches in the July-August issue of NBAA's Business Aviation Insider, available at nbaa.org/FGV approaches. Be sure to also follow this and other safety advances in our industry at nbaa.org/safety. And that's the latest from the National Business Aviation Association. Remember, you can subscribe to Flight Plan wherever you find your favorite podcasts, or by asking your virtual assistant or connected device. Of course, you can also download episodes directly from nbaa.org. I'm Rob Finfrock. Thanks for listening, and join us next time for a new episode of Flight Plan.
Right base, sending out 3500.
All right, we got him inside. We're still on effect 170,